And wavelength division multiplexing is commonly used in case of optical fiber, and particularly we have observed that optical fiber medium provides enormous bandwidth, and since it provides enormous bandwidth and WDM is the most viable technology that overcomes the huge optoelectronic bandwidth mismatch. Here the mismatch is coming because the optical fiber has very high bandwidth, individual users bandwidth requirement is much smaller. So, we have to send a large number of signals through the optical fiber, or we would like to the optical fiber bandwidth has to be shared by the signal of a large number of users. How that can be done? That can be done by using wavelength division multiplexing. It is somewhat similar to frequency division multiplexing, but at these higher frequencies normally we refer to frequency division multiplexing as wavelength division multiplexing, because wavelength value is smaller. So, wavelength division multiplexing optical fiber network comprises optical wavelength switches or routers interconnected by point to point fiber links. That means, there are switches and routers. That means, you have got say switch or router, and you have got optical fiber cable, and then this switch can receive a number of signals, and switch can also separate out a large number of signals. So, this is how it is being done, and this is your optical fiber cable. Now, end users may communicate with each other through all optical channels known as light paths, which may span over more than one fiber links. Here I have shown only one link, but you may not have only one link. In between there may be more switches, and as a consequence the optical signal, the light signal can pass through a number of switches in the optical domain, can reach the other side. So, this can happen whenever you have got optical switches, and this wavelength division multiplexing is becoming very popular, and the basic concept is shown here. Here again we have got different sources, and they are modulated with different carrier frequencies or wavelengths, as you can see. So, the bandwidth of, in terms of wavelength, a particular source say I is from W lambda 1 to lambda j. So, here for example, this is the signal coming from channel 1 lambda 1 to lambda 2, channel 2 lambda 3 to lambda 4. You can see there is some guard band in between. Then for channel n lambda 2n minus 1 to 2n. So, these different wavelengths can be multiplexed and sent through a optical fiber cable. So, this signal is going through an optical fiber cable, signals or optical signals of different wavelengths, and at the receiving end they can be separated out, and that filtering can be done, and we can get different frequencies, different wavelengths, as you can see here lambda I to lambda j meant for a particular channel. You may be asking how the filtering is done in optical domain. You may remember in your school days you have done experiment with prism. So, here as you can see the light coming out from the other side of the prism depends on the incidence angle and the wavelength. So, the lights can be made incident to this side with different angles, so that all of them come out with the same angle from the other side. Then it can be sent through optical fiber cable. At the other end again they can be separated out by using another prism. So, this is a very simple example which shows how wavelength division multiplexing can be done, how the different light signals can be combined and then can be sent through a single optical fiber, and again they can be separated out at the other end with the help of prism. So, somewhat similar devices can be used in practice in wavelength division multiplexing. Then coming to the digital one, that time division multiplexing, we have discussed the FDM and WDM, which uses analog signaling as we have seen, and now we shall consider time division multiplexing and two types, synchronous and asynchronous.